Hello to my viewers around the globe. I'm Musa Yusuf Buhari, MB diet therapist. So today I would like to make presentation on lipid metabolism. When we talk of lipid, we are referring to as one of the class of food that is insoluble in water but soluble in organic solvent that is non-polar in nature, such as chloroform, benzene, ether, alkanol or alcohol that is hot, acetone, and so on and so forth, can allow lipid to be dissolved in them. Now, lipid consists of fat and oil. When we are talking about lipid, we are virtually talking about fat and oil. That is what we mean by lipid. So, lipid that is fat. Fat means lipid that is solid at room temperature is called fat, while oil referred to as lipid that is liquid at room temperature. Now, chemical composition of the lipid. The constituent of the lipid composed of a complex molecule, such as the glycerol is one of the constituent or chemical composition of the lipid, fatty acid, and also just like the way carbohydrate is existing with carbon, hydrogen, and oxygen, so also lipid has carbon, hydrogen, and oxygen, but it contains few amount of the oxygen compared to that of carbohydrate. And this is one of the reasons why lipid supply more energy in the body than that of the carbohydrate. So 1 gram of the lipid when oxidized produce about or supply the body about 9.1 kilocalorie per gram, while that of the carbohydrate produce about 4 kilocalorie per gram and also the protein. So this means that 1 gram of lipid supply about one fourth of energy times that of the either carbohydrate or protein. Now, it is very important to talk of lipids. So, the chemical composition consists of the carbon, hydrogen, and oxygen, but fewer amount of the number of the oxygen in that. Now, classification of the lipid. Lipid is generally classified into 3 groups. We have what we mean by the simple lipids, compound lipids, and then precursor and derived lipids. These are the 3 classes of the lipid that we have. So, when we talk of simple lipid, it forms as a result of esterification. It is an ester of fatty acid and glycerol. That is what we mean by and glycerol. That is what we mean by simple lipid. An example, we have triglyceride. It is an example of simple lipid. We also have wax or waxes. These are also examples of simple lipid. Now, but waxes exist mostly in insects and plants. So we focus more on health aspect of the lipid. So we're going to put more emphasis on triglyceride. Triglyceride, it is one of the example of the simple lipid that is formed as a result of reactions between the glycerol, which is 3 carbon alkanol, and fatty acid, 3 molecules of the fatty acid. For example, let us look at the chemistry or the chemical reactions of the formation of the triglyceride as the simple lipid. Consider C3H5 3-hydroxyl functional group. This is glycerol. 1 molecule of the glycerol, which is the alkanol, plus 3 molecules of the fatty acid to produce glyceride as the simple lipid, which is the neutral lipid that is usually found in the body, plus the water. It is a condensation reaction. It eliminates water. Now, the fatty acid is three molecules, while the glycerol, which is the alkanol, is one molecule. In this can be expressed in this way. This is our glycerol plus three fatty acid, which can be represented as R, double bonding carboxyl functional group of the acid. This is our fatty acid, but three molecules of the fatty acid to produce this compound. So to understand the structures or chemistry of this, you need to go back to reflect back to organic chemistry in the basic level. To have this, it will eliminate water. Let's see, this is the first side chain. This is the ester bonding. This is the second alkyl group. So this is plus water. 3 molecules of water. This is triglyceride. This formula or this structure is called triglyceride, which is a simple lipid. Now, the triglyceride that we have, it is a neutral lipid. It is usually stored in the food and in the body within the adipose tissue. It is one of the lipids that is neutral, which is stored in the body in the fatty tissues. That is the adipose tissue. So, talking about, since we have our triglyceride, this is the first reactions showing simple lipids or formation of simple lipids. For what this, we are not going to lay more emphasis. It is a simple lipid that consists of a larger weight number of the alkanol, which is monohydrate, meaning it contains single functional group of the alkanol group and a fatty acid to form a waxis. Usually it exists in insect and some plant to repel water away from the plant or to protect the plant against certain water infiltration into the system. So for the compound lipid, which is the number 2 group of the lipid or the second group of the lipid, this is a simple lipid, but in addition it has other moieties or constraint of the element that can attach to this group to make it a complex or a compound lipid, such as phosphoric group, nitrogenous group, protein, carbohydrate, sulfur group. All when they attach to the simple lipid, it becomes a complex lipid or compound lipid. For example, compound lipid, it forms. Let's look at our triglyceride, which is the first example of the simple lipid in this form. This is our triglyceride. Now, if phosphoryl group is being attached to this carbon, one of the carbon of the alkanol, which is the glycerol, it forms a phospholipid. So this is a phospholipid, which is a common example of phospholipid, which is common example of compound lipid. This can allow either sulfur to be added to this, nitrogen group, carbohydrate such as glycoprotein, glycolipid, sulfolipid, aminolipid, sphingolipid, all are common examples of compound or complex lipid. The third classification of the lipid, it is different from this. It is not a form of triglyceride lipid, mostly a derivative or precursor or lipid that has to do with uh, fat-like substances such as sterols like the cholesterol in the body, which is produced by the liver. It is an example of derived or precursor lipid like the glycerol, because when lipid is being digested or is being uh, splitted in the body during digestion, it can split to give the free glycerol and the free fatty acid. So the free fatty acid and the glycerol, it is also an example of derived lipid. So these are the three classifications of the lipid that we have. Now, let us look into the fatty acid. Fatty acid. Fatty acid, it is also a lipid. It can be saturated fatty acid. There are two groups of the fatty acid and unsaturated fatty acid. So when we talk of the saturated fatty acid, this is a type of fatty acid that consists of a single bonding in the chain of the fatty acid. And unsaturated fatty acid is a type of fatty acid that consists of a double bonding in between the carbon atom in them. That is the difference between fatty acid that is saturated and unsaturated fatty acid. There are various examples of fatty acid that are saturated and unsaturated. Let us look at the examples and then identify how this one is saturated and this one why it is unsaturated fatty acid. Valeric acid, so now these are saturated fatty acids. Valeric acid, mystric acid, palmitic acid, stearic acid, all they consist of a single bonding. For example, mystric acid consists of a 14 carbon atom acid, while this one consists of a 16 carbon acid, while the stearic acid consists of 18 carbon acid. From the structure, if we can look at them, this is the chemical structure of mystric acid. Very good. So this is the functional group of the acid. This is the functional group of the acid, which is COOH. These are the hydrogen atom attached to the acid. Side chain. So to minimize this one, you can represent it in this form. The CH3, CH2, since it is 14 carbon atom, of course, this can be 10, then COOH. to minimize the expression. It's also another form of writing this. This is mystric acid. This is the functional group of the acid, carboxylic group, and then this is the methyl group. So the first carbon immediately after the functional group is called the alpha carbon. This is the alpha carbon. And then this is the omega carbon. So fatty acid consists of the alpha carbon and the omega carbon. This will help in expressing omega acid. So the same way, the same pattern of writing, you can express the mystric acid, palmitic acid, stearic acid, and whatsoever saturated fatty acid. In between the carbon atom, it is single bonding that is existing between them, and the number of the hydrogen atom is complete in this type of acid. That is so-called saturated fatty acid. Now, unsaturated fatty acid. This acid consists of double bonding in between the carbon atom. It can be monounsaturated fatty acid, polyunsaturated fatty acid, or eicosanoid fatty acid. When we talk of monounsaturated fatty acid, it is unsaturated acid that it consists of single double bonding in them. While polyunsaturated fatty acid, it is a type of fatty acid that is unsaturated that consists of either double or triple bonding in between the carbon-carbon atom. Then eicosanoid fatty acid that is unsaturated. It is a type of unsaturated fatty acid that consists of number of carbon atoms between 20 and above. That is eicosanoid unsaturated fatty acid, like the arachidonic acid. Now, talking about unsaturated fatty acid, we have example like we have oleic acid. This is an example of that. We have linoleic acid. It is also an example of it. We have linolenic acid. This linolenic acid can be gamma linolenic acid, or it can be alpha linolenic acid. There are two types. So there is a way of representing this in a formula. For the oleic acid, it is 18 carbon acid. This is omega 9 fatty acid. The first number, the 18, is representing the number of carbon atom. Then the second number is representing how many double bonding does the oleic acid have. And then the last number is representing at what position does the double bonding exist. For example, for the oleic acid, let us look into the structure or chemical form of the oleic acid and see. Now, from the omega carbon counting, when we started, we say that it is 18, 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Our total number of carbon atom is completed. This is our omega counting carbon atom, which is the methyl group. All is carrying hydrogen atom in them. So now, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the double bonding landed at this position. That is the position of the double bonding, which is this 9. So hydrogen atom can be either on this orientation, or it can change the orientation. So as such, the hydrogen atom, you can complete the structure if you like, but for the sake of time, I don't think it is more. This does not contain hydrogen. That is why it is unsaturated fatty acid. Fatty acid can be essential and non-essential. When fatty acid is essential, meaning that the body cannot produce that. So when fatty acid is essential, it means we can get them from our diet, meaning that our body cannot synthesize. That is why it is essential. And it is very important for our health, for our management of our nutritional well-being, to make use of the essential fatty acid, such as arachidonic acid, linoleic acid, and linoleic acid. They are the three essential fatty acids that we have. And these are from mostly vegetable oil and from fish, like uh, fish contain omega-3, omega-6, and what have you. So oleic acid, it is omega-9 fatty acid. To understand why it is omega-9 fatty acid, because when you subtract 9 from 18, you find that it is 9 that will be left. So that is why it is omega-9 fatty acid. For this linoleic acid, we have 18 carbon atom in them. The carbon atom is also 18. It is omega-6 fatty acid. So C18, double bonding, it has two double bonding, and then it is what? 12. If you subtract 12 from 18, you find that what will be left is 6, because 18 minus 12 is 6. So linoleic acid consists of 18 carbon atom, two double bonding, and then the position of the double bonding is at position 6 and 12. So if you express this just similar way of the other one that I've written, you find out that you have 18 carbon atom like this. This is the functional group of the acid. So when we start counting, we find out that from here, that's our alpha, that's our omega carbon atom started counting. So we can find that 1, 2, 3, 4, 5, 6, 7, 8, 9 at position 6. 1, 2, 3, 4, 5, 6. So meaning that double bonding can be here, and then only 2 hydrogen can be present on that, because of it is deficient of 2 hydrogen atom. So, and at position 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the other double bonding can be present here within here, meaning it will have only 2 hydrogen atom, and it will be deficient or deficient of 2 hydrogen atom. This is the common structure of the linoleic acid. It is an 18 carbon atom. So from this writing, it means that excuse me, it means that it is omega-6 fatty acid. While for the linoleic acid, which is the gamma and the alpha, it is omega-6 for the gamma, while for this one it is omega-3 fatty acid. So linoleic acid has 2 type of acid, the gamma and the alpha. The gamma, it means it is omega-6 fatty acid, while the alpha, it is omega-3 fatty acid. So with this, I've come to the end of this presentation. So in my next edition, we're going to discuss on beta oxidation. So thank you very much for your audience. Like, share, and comment. We meet in the comment section. I'm Musa Yusuf Buhari. Have a nice day.